Okay, integral notation and Riemann sums. So on this graph, it is named R of t, they tell us, and it represents the number of telephone calls made per hour on a Tuesday. Okay, and approximately how many calls were made between 9 p.m. and 11 p.m. So those are the values we really care about. 9 p.m. and 11 p.m. is kind of illustrated on our graph. So the first thing is express this as a definite integral, and then we're going to approximate it with a Riemann sum, and I'll talk us through that. All right, so for a definite integral, we need our integral symbol. It's bounded by a lower bound of 9 and an upper bound of 11. Next to that, we place our function. Ours is named R of t, and then after that, we want to put a dt because our variable is t in this case. So that's how you can represent it with a definite integral. The next thing is approximating this using a Riemann sum. So it's been done down below here. They use left-hand limits. So what you do is you would start at the left-hand endpoint, right, the bound of integration, that 9, the lower bound. Go up to the curve. That's going to be the height of a rectangle that you draw over to wherever your next one's going to start. Now it looks like they split this into 4 rectangles. So that first one occurred at 9 o'clock. The base here is only 1/2 this time. All right, so when we plug 9 in to the function, we got 100. That's this first value, multiplied by the width of that rectangle is going to be 0.5. And then we're on to 9:30. So this is like our 9 p.m. rectangle. This is our 9:30 rectangle. As you can see, what happened there was they plugged 9:30 in, or 9.5, whatever it's going to be. They estimate this to have a y value of this point right here on the graph of 150. All right, so that went for the height of that rectangle. When they drew it over, they only drew it over till 10 o'clock. All right, so the width of this rectangle is only 0.5. Okay, the next one continues on at 10, and then 10:30 for the last one. Hopefully this makes sense as they're approximating the height of the rectangle at 10 o'clock was 180. So 10 o'clock goes up here. They say that has a y value of 180 multiplied by the width of this rectangle, 0.5. 10:30, drew it up to the function. See that there are 195 calls coming in, multiplied it by the width of the rectangle, which is 0.5. After you've done all these computations for the areas, what we're going to do is add them together. Take a summation and get 312.5 telephone calls in between 9 p.m. and 11 p.m. Now this is going to be an underestimation because of what's going on with the graph and our rectangles. Because we use left-hand endpoints, we didn't account for some of these calls, right? There's a gap here between our graph and where the rectangles start. Still a gap here, another gap. They're getting smaller as I move up here, but there are small gaps in between the curve and the rectangles. So we've underestimated with this Riemann sum, but that's okay.